all the buildup of unused resources. So yeah, manuscripts, they have their own problems. They do not scale. They're prone to mistakes. And again, they will lead to more dumpster fire moments and potentially incidents. So the solution is Swabbie. We found the solution is Swabbie. So Swabbie was built to solve all these problems, the problems that we just went through, learning from the lessons from, past lessons and failures from previous solutions. And so because automatic deletion of a mass amount of resources is very dangerous, a huge focus is placed on safety as part of the core functionality of Swabbie. We'll talk a little bit about what that means in terms of exclusion policies, how Swabbie reevaluate resources before deleting them. It's very configurable, reliable. As a Spinnaker, as a first-class Spinnaker service, adheres to the same standards for operations as the rest of the services. A lot of visibilities, metrics, dashboarding. We have a lot of that. I thought I had to throw this one in here. So this is a graph of images, AMIs that were deleted in a test account at Netflix. You notice the dip. What happens here is Swabbie. So we went from over 300,000 images in the account to, as you can see, way less than 150. That's huge. That's over 100,000. And this was just for a few days. So you can imagine for a few accounts across a longer time frame.
That was just one region too?
This is the orange line is just one region.
Oh.
Yeah. So before we move forward, let's cover some definition. We've been talking about a resource already. Resource is a cleanup candidate. For example, server groups, firewalls, or security groups, AMIs, etc. Resource handler is basically a component that understands a particular type of resource. And a resource handler is tied to a lifecycle of a mark, notify optionally, or delete. Marking is the concept of marking is scheduling a resource for deletion. A rule is employed by a handler to decide whether or not a particular resource is valid or not. A work configuration or resource-specific settings. We'll see what the configuration looks like in a little bit here. Work item is a combination between an action and a configuration or setting for that resource type. And a work queue is exactly that. It's just a work queue. We all have work queues. So how does Swabbie work? Let's look at how it works. High-level overview of what the architecture looks like, the main components. First is the Spring Boot application, similar to other Spinnaker applications, Spinnaker services, and it's written entirely in Kotlin, which is awesome. And first, let's quickly look at the configuration. Swabbie heavily relies on the configuration. And in the configuration, you can define things like how often does Swabbie work, and how often the queue of work is monitored and refilled with work. And in this example here, we have it set up for images. You can enable what actions are available for Swabbie and notification settings. This is a shortened version, a snippet of what the configuration really looks like. So at startup, this configuration is flattened into single units of work called work items that are placed on the queue. And the system, actually Swabbie, makes sure that no work is being processed during off hours, for example, or when the service actually reports itself as down in service discovery. So you may recognize some of the internal services inside of Spinnaker. Gate, which is Spinnaker's API gateway. Cloud driver to perform cloud operations. Orca is actually in charge of handing the deletion task to cloud driver to perform it. We use From 50 to get application metadata, to also get the ownership information, and then Echo for notifications. That's it. So, right, and the source of truth is the cloud. Swabbie is designed to not really be centered around a specific cloud. There are a lot of abstractions, so that means that you can use it as a orchestration engine for deletions. But for now, AWS is the default cloud provider. Okay, so how does Swabbie gets the work done? By rolling those barrels in. Yeah. So work is routinely taken off the work queue. But before anything gets processed, a lock is required to make sure that Swabbie instances don't step on each other, so it's used for coordination. Once the lock is acquired though, a suitable handler, in this case it will be let's say an image handler. A suitable handler is found and the work is delegated to it. And finally, that handler calls the requested action. In this case, the action is mark, and the configurations are resource-specific configuration. All right, so let's quickly talk about marking, which is an important step inside of Swabbie. So marking is, in this case, it's an image handler. It starts off by fetching resources from the cloud or the data source, evaluating them, ignoring everyone on which exclusion policies actually apply. All resources that are opted out are also ignored. And finally, we run all resources through a rules engine to make sure that they're valid or not. Valid resources are excluded, and the ones that actually violate the rules, we notify on them. And if you have entity tags enabled in Spinnaker, we put a nice little UI alert, and I'll show that in a second. And we also we schedule the delete, and the delete is done by just keeping track of all resources that are marked for deletion. Deletion follows the same pattern because we want to make sure that whatever is being deleted gets reevaluated at deletion time. And we also want to make sure that we keep a snapshot of the resource that we're deleting, so that when somebody comes back and say, we deleted something really important, then we can look at what happened, we can look at the audit trail, and see the last state of the resource before it got deleted. And that can help in troubleshooting or maybe even recreation of the resource if there was a bug or something like that. We talked about storage, so let's quickly touch on that as well. Swabbie uses Redis to store marked resources currently. There's a nice little interface in it, so a data store really can be implemented. It can support any data store. Like I said, marked resources, we keep track of them in Redis. I believe they're kept in a sorted set. And we also keep track of every resource state, example for opted out, delete, notified, and marked. Redis also powers the log manager that we use for coordination amongst worker nodes. I mentioned earlier notifications. Notifications are also important, a part of the resource handler lifecycle. Once marked, Swabbie determines the owner of the particular resource and sends out a notification. An email notification will look like this one. Opting out of deletion is as simple as clicking the button, the right button over there. And because all of us are subject to notification fatigue, So sometimes we miss notifications, but Swabbie also adds an alert in the UI to quickly grab your attention when you're viewing your clusters. Again, you have the option to opt out in here or to read more about resource cleaning. Okay, safety. As I mentioned earlier, automatically deleting batches of resources is dangerous. Please don't do it. It's really dangerous. So the wrong deletion can easily take out your services. You can go offline easily if you delete the wrong thing. You might make some headlines in the news. Definitely do not want that. But fear not. Swabbie was designed with that in mind, with safety as part of the core. So there are features inside of Swabbie that actually help you limit the blast radius of an accidental delete or a bug. So here are some key safety features. Schedule, for example. Swabbie can be restricted to run following a strict schedule, working 9 to 5 like the rest of us. It ensures that everyone is in the office and ready to help if there is an ongoing incident. You definitely do not want to ruin somebody's weekend or somebody's night. So be a good citizen and restrict it to 9 to 5 business hours. Exclusion policies, we'll talk about them, and allow listing, they're very powerful. Another way of limiting the blast radius is setting an upper limit on how many instances or how many resources that you get to process per cycle. This will help reduce, again, like I said, the blast radius. Okay, exclusion policies are a very, very powerful feature because it allows us to test out new functionality and only allow list or whitelist a subset of resources that are owned by team members. And they're very flexible. In this example, for example, we are saying that this policy will apply for any resource with a name containing the substring base. Or starting with CDE, this is our persistence team at Netflix, and base, that's to avoid deleting anything that is that contains the name base in it. Similarly for Titus agent, we do not want to delete those, so we exclude them automatically. So any resource attributes can be used to exclude or allow a resource out of consideration or for consideration. Tagging is also allowed. It's also a feature. So for AWS tags, for example, like you can have a resource tagged with a particular string, and then you can exclude based off of that. Same as allowed listing, like I mentioned earlier, we use this heavily in Netflix to roll out our features and gain confidence that way by gradually rolling out the features before we enable the feature for the entire company. So what is currently supported? We've been deleting AMIs for months now with a lot of success. We have not gotten any incidents or anybody complaining that we deleted, we wrongfully deleted something. So this speaks a volume to the amount of testing that go into releasing a new feature for Swabbie. So we support AMIs, auto-scaling groups, EBS snapshots, and there are more to come. But really what I'm really excited about is how we can extend Swabbie to be able to outsource the resource deletion to other teams. Make it pluggable. So we're looking to rely heavily on the plugins effort ongoing right now in Spinnaker, and leverage that to have teams actually write their own rules, write their own handlers, and plug into Swabbie. Support for functions, like lambdas, or just calling out to an external service is also something that we're really excited about. A little bit of contribution. Pull requests are highly appreciated. And pull requests are highly appreciated, but there are other ways you can get involved. The Git repo is right there. And if you want help, you can jump into the Swabbie channel inside the Spinnaker workspace. You can help us with adding support for a new resource type or testing in any way possible. It's much appreciated. So with that, I will conclude with questions for any.
Okay, so you say you were using Swabbie to clean out some EBS snapshots, right? But what was the use case for that? I mean, I had clients that spend basically millions a month.
Yep.
Just had too many snapshots and it's very difficult to clean up. So how did you configure Swabbie to do that?
Yeah, so the EBS snapshots that we clean inside of Swabbie are EBS snapshots of AMIs that have already been deleted. So we keep track of all the AMIs that are deleted, and we know that once this AMI is deleted, then we know this snapshot is useless, and we go ahead and delete it.
So that's not pattern matching. So how did you write the logic to see, okay, because this is deleted, therefore anything tied to it is, so I'm not quite seeing that.
Oh, no problem. So every handler has custom code to actually do a lot of that reasoning. So an image handler has the custom code to say, you can get pretty creative with determining which ones are used or not. So inside of the image handler, we have logic in there to say, this image gets deleted, then every associated references will also get marked for it.